Download this code from codegive.com, link in the description below. Business Logic Vulnerabilities, Infinite Money Logic Flaws and portswigger Lab Tutorial. This tutorial will delve into business logic vulnerabilities, specifically focusing on infinite money flaws, and provide a detailed walkthrough of portswigger's business logic vulnerability, Infinite Money Logic Flaw Lab. We'll cover 1. What are business logic vulnerabilities? 2. Infinite money logic flaws explained. 3. Identifying and exploiting infinite money flaws. 4. Portswigger Lab walkthrough, infinite money logic flaw. Asterisk lab setup. Asterisk identifying the vulnerable workflow. Asterisk crafting the exploit. Asterisk executing the exploit. Asterisk mitigation strategies. 5 code examples, illustrative, not lab specific. 6 preventing business logic vulnerabilities. 7 beyond infinite money, other types of business logic flaws. 8 tools and techniques for finding business logic flaws. 9 conclusion. 1. What are business logic vulnerabilities? Business logic vulnerabilities are flaws in the design and implementation of an application's workflow, rules, and processes. They arise when the application's logic doesn't handle exceptional or unexpected scenarios correctly, allowing attackers to manipulate the intended functionality for malicious purposes. Unlike typical vulnerabilities like SQL injection or XSS, which exploit coding errors, business logic flaws exploit how the application functions. These vulnerabilities often stem from incomplete or flawed validation, insufficient checks on user inputs and data integrity, incorrect state management, mishandling of application state during a transaction or workflow, missing or inadequate authorization checks, failing to properly verify user permissions at each stage, poor error handling, revealing too much information or allowing inconsistent states after an error, race conditions, exploiting timing issues when multiple actions occur concurrently. Business logic flaws can have severe consequences, including financial losses, example unauthorized transactions, inflated balances. Data breaches. Reputational damage. Service disruption. 2. Infinite money logic flaws explained. An infinite money logic flaw is a type of business logic vulnerability that allows an attacker to artificially increase their funds or resources within an application. This usually involves exploiting a flaw in how transactions, discounts, or promotions are processed, leading to a positive feedback loop that generates money out of thin air. Common scenarios leading to infinite money flaws. Flawed refund processing, receiving a refund without returning the original item, then repeatedly purchasing and refunding. Abuse of discounts or coupons, using coupons multiple times when they should be single use, or combining discounts in unintended ways. Exploiting race conditions in transactions, making the same purchase multiple times nearly simultaneously, leading to over-delivery of goods or services. Manipulating balance transfers, transferring funds between accounts and exploiting inconsistencies in the timing or validation of the transfer. Decimal precision errors, exploiting rounding errors in financial calculations to accumulate small amounts over time. Less common for infinite money, more for gradual accumulation. 3. Identifying and exploiting infinite money flaws. Identifying infinite money flaws requires careful analysis of the application's business logic and workflow. Look for recurring transactions, identify workflows where transactions or actions can be repeated multiple times. Asterisk discounts and promotions. Asterisk analyze how discounts, coupons, and loyalty programs are implemented and whether they can be abused. Asterisk account balance handling. Asterisk examine how account balances are updated, transferred, and refunded. Asterisk error handling. Asterisk observe how the application behaves when errors occur during transactions. Asterisk data validation. Asterisk test the application with invalid or unexpected inputs to see if it can be manipulated. Exploitation typically involves 1. Identifying the vulnerable workflow. Asterisk find the process that allows for manipulation. 2. Crafting the exploit. Asterisk design a series of actions to trigger the vulnerability and generate artificial funds. 3. Executing the exploit. Asterisk repeatedly perform the actions required to increase your balance. 4. Automating the exploit. Asterisk use scripts or tools to automate the process and maximize the gains, optional but often necessary for large-scale exploitation. 4. Portswigger Lab Walkthrough, Infinite Money Logic Flaw. This section will guide you through solving Portswigger's business logic vulnerability, Infinite Money Logic Flaw Lab. Lab description. Asterisk. This lab involves purchasing a gift card and then using the gift card to buy another product. There's a vulnerability where the gift card can be used repeatedly to make purchases, essentially providing infinite money. Lab setup. Asterisk. 1. Log into your Portswigger account and access the business logic vulnerability, Infinite Money Logic Flaw Lab. 2. Activate the lab. This will give you a unique URL for the vulnerable application. Identifying the vulnerable workflow. Asterisk. 1. Explore the application. Asterisk. Browse the website, add products to your cart, and go through the checkout process. Pay attention to the payment methods available. 2. Notice the gift card option. Asterisk. The application offers the ability to purchase and use gift cards. This is the most likely area to investigate. 3. Buy a gift card. Asterisk. Purchase a gift card for a small amount, example $10. Note the gift card code that is generated. 4. Try using the gift card. Asterisk. Add another product to your cart and attempt to pay with the gift card. 5. Observe the behavior. Asterisk. After using the gift card, does the application invalidate the card or reduce its balance? This is the key question. In this lab, you'll find that the gift card is not invalidated after being used. This is the vulnerability. Crafting the exploit. Asterisk. The exploit is quite simple. 1. Purchase a small value gift card, example $10, this provides you with a reusable payment code. 2. Add a product to your cart with a higher value than the gift card, example $100 laptop. 3. Use the gift card code as payment even though the gift card value is less than the product's price, the application allows you to proceed with the purchase. You might need to enter other payment information to cover the difference. The crucial point is that the gift card is still valid after this purchase. 4. Repeat step 3 to purchase more expensive items, effectively using the same $10 gift card over and over. Executing the exploit. Asterisk. 1. Purchase a $10 gift card. Note the gift card code. 2. Add a more expensive item, example the $1,337 leather jacket, to your cart. 3. Proceed to checkout. Use the gift card code as payment. The application might show a remaining balance. Enter dummy credit card details for the rest. 4. Complete the purchase. 5. Repeat steps 2 to 4 until you have purchased a substantial amount using only the $10 gift card and dummy payment details. You'll have infinite money in terms of purchasing power. 6. Solve the lab. Asterisk. Once you've purchased enough items, the lab will be marked as solved. The exact criteria might vary. You may need to purchase a specific item or reach a certain expenditure total. Mitigation strategies. Asterisk. To prevent this vulnerability, The application should 1. Invalidate gift cards after use *. Once a gift card is used, its code should be deactivated. 2. Track gift card balances *. Implement a system to track the remaining balance on each gift card and prevent its use once the balance reaches 0. 3. Properly validate payment amounts *. Ensure that the sum of all payment methods, including gift cards, covers the total purchase price before completing the transaction. 5. Code examples, illustrative, not lab-specific. These code examples are for illustrative purposes to show how these vulnerabilities can arise. They are not directly applicable to solving the portswigger lab, as you don't have access to the backend code. Example 1, Flawed gift card validation, Python, simplified. Vulnerability *. The critical missing line is the deactivation of the gift card after use, or even better, a check on gift_card.active during the use_card method. Also, the balance is decremented but gift_card.balance is never updated in the gift_cards list if it's stored in memory, leading to inconsistencies. How to exploit *. The attacker can repeatedly call process_payment with the same gift_card_code to use the gift card multiple times. Fixed code, illustrative. Example 2, discount code abuse, PHP, simplified. Vulnerability *. The code doesn't track how many times a discount code has been used. An attacker could repeatedly use the summer20 discount code to get discounts on multiple purchases. It lacks any session management or database lookups to track code usage. How to exploit *. Submit the form with discount code equals summer20 repeatedly. Fixed code, illustrative. Key improvements *. Session management * uses session_start to track the discount code usage per user. Code tracking * stores used codes in the $_session used codes array. Usage check * the apply discount function now checks if the code is in the used codes array before applying the discount. 6. Preventing business logic vulnerabilities. Preventing business logic flaws requires a comprehensive approach that encompasses secure design principles, thorough testing, and continuous monitoring. Here are some key strategies. Secure design principle of least privilege grant users only the minimum necessary permissions to perform their tasks. Input validation validate all user inputs thoroughly to prevent unexpected data from entering the system. This includes checking data types, formats, ranges, and lengths. Use whitelisting instead of blacklisting whenever possible. State management carefully manage the application state during transactions and workflows. Ensure that state transitions are handled correctly and consistently. Authorization checks implement robust authorization checks at every stage of the application to verify that users have the necessary permissions to perform specific actions. Error handling implement proper error handling to prevent the application from entering inconsistent states. Avoid revealing sensitive information in error messages. Transaction management use transactions to ensure atomicity, consistency, isolation, and durability, of operations. Rate limiting implement rate limiting to prevent abuse of critical functionalities. Thorough testing functional testing test all application features and workflows to ensure they function as expected. Negative testing test the application with invalid or unexpected inputs to see if it can be manipulated. Boundary testing test the application with boundary values, minimum, maximum, and edge cases, to identify potential issues. Security testing conduct security testing, including penetration testing, to identify vulnerabilities. Code review perform thorough code reviews to identify potential flaws in the application's logic. Continuous monitoring log monitoring monitor application logs for suspicious activity or errors. Anomaly detection implement anomaly detection systems to identify unusual patterns or behaviors that may indicate an attack. Regular security audits conduct regular security audits to assess the application's security posture and identify potential vulnerabilities. Stay updated keep up to date with the latest security threats and vulnerabilities and apply necessary patches and updates. 7. Beyond infinite money, other types of business logic flaws. While infinite money flaws are a common example, business logic vulnerabilities encompass a broader range of issues, including privilege escalation gaining access to functionality or data that should be restricted. Data manipulation modifying data in unauthorized ways, leading to incorrect information or system behavior. Workflow bypass skipping steps in a workflow to gain an advantage or access restricted resources. Denial of service, DOS consuming excessive resources or causing the application to crash. Account takeover gaining control of another user's account. Order manipulation modifying order details, example quantity, price, shipping address, after an order has been placed. Inventory manipulation falsely increasing or decreasing inventory levels. Abuse of loyalty programs earning points or rewards fraudulently. 8. Tools and techniques for finding business logic flaws. Manual code review analyzing the source code to identify potential flaws in the business logic. Penetration testing simulating real-world attacks to identify vulnerabilities. Burp Suite a web proxy that allows you to intercept and modify HTTP requests, which is invaluable for testing application logic. Specifically, Burp Repeater allows you to craft and send arbitrary requests. Burp Intruder can automate repeated requests with modified parameters to fuzz for vulnerabilities. OWASP Zap another popular web application security testing tool. Fuzzing automated testing that involves sending random or malformed inputs to the application to see if it crashes or exhibits unexpected behavior. Static analysis tools tools that analyze the source code without executing it to identify potential vulnerabilities. Dynamic analysis tools tools that analyze the application while it is running to identify vulnerabilities. 9. Conclusion. Business logic vulnerabilities are a significant security risk that can have severe consequences. By understanding the nature of these flaws, adopting secure design principles, conducting thorough testing, and continuously monitoring applications, developers, and security professionals can significantly reduce the risk of exploitation. The portswigger labs provide excellent hands-on experience in identifying and exploiting these vulnerabilities, helping you to develop the skills necessary to protect your applications. Always remember that a holistic security approach that combines technical controls with a deep understanding of the application's business logic is crucial for building secure and resilient systems. Business logic vulnerabilities, infinite money logic flaw, portswigger lab, detailed tutorial. This tutorial dives deep into the business logic, infinite money logic flaw lab on Portswigger's Web Security Academy. We'll explore the concept of business logic vulnerabilities, specifically how a flawed implementation of coupon codes can lead to an attacker generating an infinite amount of money. We'll provide a detailed explanation, code examples, both vulnerable and patched, and a step-by-step walkthrough of solving the lab. Understanding business logic vulnerabilities. Unlike classic vulnerabilities like SQL injection or XSS, which exploit technical flaws in the code related to data handling, business logic vulnerabilities arise from errors or inconsistencies in the design and implementation of the application's core business processes. These flaws often stem from incorrect assumptions. Developers make assumptions about how users will interact with the system that aren't always true. Insufficient validation. The application doesn't adequately validate user inputs or the state of the system before executing critical actions. Race conditions. Multiple actions can happen simultaneously, leading to unexpected outcomes if not properly synchronized. Lack of proper error handling. The system doesn't gracefully handle errors, potentially leaving the system in an inconsistent state. Missing integrity checks. The application fails to verify the integrity of data at critical points in the business flow. Business logic vulnerabilities are often harder to detect than other types of vulnerabilities because they require a deep understanding of the application's functionality and the expected behavior of its users. They often don't throw errors or trigger standard security tools. 2. Infinite money logic flaw. The concept. An infinite money logic flaw is a specific type of business logic vulnerability where an attacker can repeatedly exploit a process, usually involving some form of credit, coupon, or reward system, to generate an unlimited amount of value, money, points, credits, etc. This often occurs when coupon codes are not properly invalidated after use. Discount logic is flawed, allowing multiple applications or overlapping discounts. Credits are incorrectly awarded or duplicated. The system doesn't track or limit the total value awarded from a specific promotion. Returns or refunds are not correctly handled, creating a loophole for abuse. 3. The portswigger lab, business logic. Infinite money logic flaw. This lab presents a scenario where a coupon code can be used repeatedly, effectively allowing an attacker to purchase items for free and generating a profit by redeeming a gift card balance. Scenario ***. The application has a coupon code system. Users can purchase items. Users can redeem gift card balances. A specific coupon code, sign up 30, provides a 30% discount on all items. The vulnerability the sign up 30 coupon code is not properly invalidated after its first use. This means an attacker can repeatedly apply the discount on orders, bringing the total cost down to zero or even a negative value, allowing them to accumulate a gift card balance for free. 4. Vulnerable code example, illustrative, not the exact lab code. Here's a simplified example of how the vulnerability might manifest in the application's code, using Python/Flask for illustration. Explanation of the vulnerable code *. 1 Coupons dictionary *. This dictionary simulates a database of coupon codes. Each coupon has a discount value and a used flag. 2 Apply _coupon function *. This function is responsible for applying the coupon to the user's card. The critical flaw is in this line. While it checks if the coupon has been used, it never sets coupon used to true after the coupon is applied. This means the coupon can be used infinitely. 3 Negative price handling *. The code also includes this. If the discount is so large that the final price becomes negative, the negative amount is added to gift_card_balance, effectively giving the user free money. This is the key exploit condition. Exploiting the vulnerability, solving the lab. Here's a step-by-step guide to exploiting the vulnerability in the portswigger lab and solving it. 1. Browse the website * explore the online store. Identify the products and their prices. 2. Add an item to your cart * add a product to your shopping cart. Choose an item with a price high enough that a 30% discount could potentially drive the price below zero, especially if you increase the quantity. For example, add 4 jackets, 4x 100 equals $400. 3. Apply the coupon code * go to the cart page and enter the coupon code sign up 30. 4. Observe the results * you should see that the coupon has been applied. If the discount resulted in a negative total, or 0 in the actual lab implementation, you've successfully manipulated the gift card balance. 5. Repeat the process * repeat steps 2 to 4 multiple times. Each time, the negative balance, or free item purchase, is added to your account. In the portswigger lab you can add large quantities of items to your cart and apply the coupon which creates a negative price. The negative price adds to your gift card balance. 6. Redeem your gift card * navigate to the gift card redemption page. The gift card balance should have increased significantly. Redeem the gift card to solve the lab. 6. Code fix, mitigating the vulnerability. Here's how to fix the vulnerable code and prevent the infinite money logic flaw. Explanation of the fixes * 1. Mark coupon as used * the line coupons coupon _code used equals true is added after the coupon has been successfully applied to mark it as used. This prevents it from being used again. 2. Prevent negative balance * instead of allowing the negative final _price to affect the gift _card balance, the code now sets final _price equals 0. This prevents the attacker from exploiting a negative price to add money to their gift card. A more robust solution would also involve showing an error message to the user. 7. Other mitigation strategies, beyond code. Rate limiting * limit the number of times a coupon code can be applied within a specific time frame. Account verification * verify user accounts through email or SMS to prevent abuse. CAPTCHA implement CAPTCHA challenges to prevent automated abuse. Monitoring and alerting set up monitoring and alerting to detect unusual patterns in coupon usage or gift card redemption. For example, alert on accounts with rapidly increasing gift card balances. Regular audits conduct regular security audits to review the application's business logic and identify potential vulnerabilities. Input validation validate all input, even seemingly harmless values like quantities and coupon codes. Business logic testing integrate business logic tests into your testing process to specifically target these types of vulnerabilities. These tests should simulate various edge cases and boundary conditions in the application's workflows. Principle of least privilege only grant necessary permissions to users or services. This limits the impact if an account is compromised or if an attacker finds an exploit. 8. Key takeaways. Business logic vulnerabilities can be just as dangerous as technical vulnerabilities like SQL injection. Thoroughly understanding the application's business processes is crucial for identifying and mitigating these vulnerabilities. Proper input validation, error handling, and state management are essential for preventing business logic flaws. A layered approach, including code fixes, rate limiting, and monitoring, provides the best defense against these types of attacks. Always consider the potential for abuse and how an attacker might try to manipulate the system to their advantage. By understanding the principles behind business logic vulnerabilities and practicing identifying and fixing them, you can build more secure and resilient web applications. Good luck with your portswigger labs.